We are resuming our discussion of gravitational potential energy in today's lesson. Gravitational potential energy, as I defined it in the last lesson, it is work done on a mass in bringing it from infinity to a certain point in the gravitational field. If this is the Earth or any other planet, and this is the radius of that planet, let's say this is capital R, and we are initially at a very far off place from this planet, and this place is called infinity. It may be a few thousand kilometers from the surface of that planet, but it is called infinity because gravitational field ceases to exist there. Its value becomes zero there. So gravitational potential energy is defined in terms of the work that we have to do in order to bring a mass m from this point to any point A or B or C or D in this gravitational field of this planet. This work, as I emphasized in the last lecture, is always a negative number, is a negative quantity, and this is the standard expression for this quantity. There is no derivation for it. We just have to memorize this, and we should be able to recall this expression. UA, which means gravitational potential energy at this position is actually equal to minus GMM over RA, which means if I move this mass M to any other position, let's say position B, I will simply change this subscript to B and this to B, and that will be the gravitational potential energy at that particular location. If let's say B is this position, the total distance of this position from the center of the planet is RB, then GMM over capital R. So this is obviously something we can take constant, because on the surface of the Earth, the gravitational potential energy is taken constant, assuming air to be a sphere. This was the discussion in the last lecture, and one thing that we discussed was the variation of gravitational potential energy with this distance r. But in the last lesson, we did not show that variation graphically, and that is something we are going to learn in this lesson. But before that, let me remind you of what we said about the kinetic energy, the potential energy, and the total energy when we consider this object as a satellite moving in this position and